In this video, I'm going to describe lambdas in Java and show a few examples. So first of all, what is a lambda? A lambda is an easy way to do a little nugget of logic, usually behavioral logic, without a whole lot of typing and without a whole lot of boilerplate code. Well, it's similar to a method, but with a lot less syntax and doesn't require a method name. It's basically like a static function that doesn't belong to a class. A lambda can implement a functional interface or an interface which just has one abstract method. And lambdas tend to be very simple, and if they return a value, they do it very quickly. Lambdas can be stored in a variable, which is critical to higher order functions, which is where we can essentially pass functions to functions. And we'll see this used frequently in stream processing. Lambdas were first added to Java in Java version 8, although we'll see them used in a lot of other programming languages as well now. So here's basically an overview of Lambda syntax. We'll typically have a parameter, and then the dash and the arrow, which we can call an arrow token. Now, this is a very simple lambda because it only has one parameter and a one-line expression. We could have 0 parameters, we could have multiple parameters. So we see if we have multiple parameters, we'll typically enclose them in parentheses and then separate them by commas. And then we can follow that with a one-line expression. Now, the trick with the one-line expression is we can't do things like if test or loops or anything like that. But there's an option to have multiple lines within a lambda expression. And typically for that, we'll have our parameters like we have here, and then we'll add curlies, which makes it look a little bit more like a method, but does give us that multi-line capability. Now, speaking of methods, let's consider what a typical method looks like in Java, and what that would look like if it were a lambda. See, here I have a method called public void vehicle output, and it accepts a parameter of type vehicle with a capital V, and that parameter name is vehicle with a lowercase v. It takes that vehicle and it invokes the go method and runs that 100 units. Now down below I have a for loop, and the for loop is iterating over a collection of vehicles. Each time it shakes hand with a single vehicle, it stores it in a variable called vehicle, and then it invokes this vehicle output method defined above. So let's see how we can use lambdas to simplify this, and let's connect the dots and see how the lambda compares to this traditional method. First of all, we're going to take this implicit variable called vehicle. We'll move that down, and we'll add that arrow operator, or the arrow token, or that goes into. Next, let's look at this logic, which is in vehicle output, and we'll move that down right after that arrow operator. Now, the rest of this method signature just goes away. We don't need all the syntax, the method signature, the curlies, all that stuff. It simply disappears. So you see, already we're saving a lot of typing. Now let's take a look at this for loop, because we can simplify that as well. We know we're iterating over a collection of vehicles, so let's take that collection of vehicles and move that up. And then let's add the for each operator to that. And typically we'd need to add a dot stream first, so just FYI, I've shortened that a little bit. So we start with the for each operator in an open paren, and then we add a closed paren and a semicolon to terminate that line. And then we can get rid of that for loop entirely. And so you see what we've done is we have taken a whole lot of code and we've simplified it and consolidated it into just one line. Now, I mentioned that a lambda will typically implement a functional interface, which is an interface with one abstract method. We could write one, or in a special case, we can use one that's predefined for us. There's one called consumer, which is a functional interface where we can store a lambda that has one input and no return value. So for instance, we see here we are making a consumer, passing in the generic type vehicle. Now that's the input. That's very important. That's the data type for the input. And we're storing this in a variable name method. Now the lambda takes that one parameter vehicle and assigns it to the variable v. And then we have our arrow token, which oftentimes will say goes into. So v goes into this lambda expression. Now I have a multi-line lambda expression here. And you see we have print line, and then we tell the vehicle to go, and then we have print line again. None of these require returning any value. So we're effectively taking in the vehicle, and we're doing some operations on it, but we're not returning anything. Now we can take this method and we can pass it to a for each, kind of similar to what I showed before. So that's a handy thing if you just need to do one quick operation that doesn't have a return value, but does accept one parameter. So with all that being said, let's see how we can create a couple of lambdas in our project. I introduced a similar lambda not long ago in our driver form class, which represents the user interface that the user will interact with, specifically the controller for that user interface. So we see here, similar to that slide I just showed, we have all vehicles, and then we get a stream from that, and then we invoke for each. And here we're saying vehicle goes into vehicle.go distance. So effectively what we're doing here is we're starting with a collection of vehicles, doing a for each, so shaking hands with each of them. Each time we shake hands, we're running this very simple operation of just saying vehicle.go. But you see that we're doing it without having all of the syntax that's involved with a traditional loop or anything like that. It's a simple one line, and we put our simple lambda expression here, and we pass that into the for each. And that's where lambdas are very valuable, when we just need to do one simple operation without a whole lot of decisions or anything like that. Now, let's take a look at Inventory Reader, because I do have here a traditional loop. And if this looks a bit familiar, it probably is, because it's very similar to that demonstration I had, or the example I had on that previous slide. So let's go ahead and take all this logic, and I'm going to wrap it in a curly, so basically make a block out of it. And then let's assign it to a lambda and save it into a consumer variable type. Remember that we're operating on a vehicle. That's what's getting passed in. So that's what I'm going to supply as my generic operator here. Consumer vehicle method equals. Now, we still need our arrow token or our goes into operator, and we need to name the parameter that's getting passed into this lambda. So we'll say vehicle, and then our goes into operator. And you see all of a sudden, almost all the red lines are gone, although I do need to terminate this entire unit with a semicolon. Now, the for loop here, we can effectively get rid of that, although I'm going to save part of it. If you remember from the animation, we're going to save the collection that we're iterating over. So we'll say all vehicles values, and then for each, and then we simply pass in that method. And this will work the same as it did before. It's simply using this lambda syntax. Now, the handy thing is I could take this entire unit out, you see, and I could move it up here, make it private and static. Now we go back down, and we'll notice that, yeah, this still works down here. Now, extracting that method and putting it up here where we're declaring our attributes is handy if we're going to use this logic in multiple places. So this is really good for reuse. So I might have multiple for loops that are doing a similar thing. Then I can just take that logic, pull it out, put it here. And I don't necessarily have to declare it right here at the very top. I could declare it somewhere else and make it accessible. But nonetheless, we see we've declared this method here, and we're using the method here. Now, the neat thing is, you notice I've set a couple of breakpoints. Let's watch what happens when I debug this class. The breakpoint has stopped in run vehicle. Now, I've built this class over a series of videos, and if you didn't happen to watch those previous videos, I can just show you a little bit about what's going on here. We start with our main method, which is naturally where a class starts in Java. We go to create vehicle, and I'm reading in a file of vehicles, so some data that I have about vehicles in the file. After I read them in, I invoke this run vehicle method. And this run vehicle method has our for each loop, which is going to iterate over every vehicle and run it a certain distance. And we know that's the logic that we've extracted and put up here in our lambda expression, which we're now saving to a variable. So I set a breakpoint there as well, and we can watch if I choose step over, look what happens next. It goes right up to this lambda expression, and the debugger continues from there. And it's going to do this for several vehicles, so we'll actually see it going over this a few different times because I have several vehicles in that file. And nonetheless, we've just wrapped up. And let's consider one more thing, which is this concept of a functional interface. So we know that an interface is typically a list of methods. And prior to Lambdas, we would have to create a class and implement that interface and then override those methods and provide an implementation for them. But with Lambdas, that's not necessary. If we have a functional interface, we can implement it with a Lambda. So, interface with one abstract method, and the abstract method signature matches the Lambda signature. Those are the two rules that we have to follow. In our project, I just happen to have a functional interface that I created earlier, which is this thing called low emission vehicle. And it has a method, an abstract method called void apply tax rebate. Now, I'm just going to kind of play in a sandbox. I'm not going to add to my program or anything, but I'll run back to our inventory reader. And let's say that I wanted to implement this the old way. So you see that I need to create a class. I call this one Bolt, like a Chevy Bolt, and then implements low emission vehicle. Then I override apply tax rebate, which is that single abstract method that exists in that interface with the entire signature. And in this case, as I say, I'm just kind of doing a demo. So I simply print out the amount that's passed in. Now, if I want to invoke this, let's say, for example, just up in this run vehicle method, I could say, low emission vehicle is an interface type. We know with the solid principles, dependency and version, our variable should be interface type. We call it bolt and then equals new bolt and then bolt.apply tax rebate 100. So if you take a look at all the lines we created here, we have our class we've created that implements the interface, and then we have the call to that class. Now let's consider what that would look like if we use lambdas instead. That's it. 2 lines. So you see that we're declaring our variable, this time called volt, also of type low emission vehicle. And we're simply saying, well, because it's a functional interface, we have this lambda, which matches the signature that we have here. We are accepting an int, and we are returning void, essentially. So it accepts that same signature. And here's our incoming parameter, that int called amount. And then here's what it does. And then we simply invoke that in a total of 2 lines, where you see what we're saving here is all of this construction here by simply using a lambda. Up above, this is fairly similar, the way we're constructing this. So we'll say that these 2 net out. A little bit of difference there because we're instantiating an object here versus setting behavior over here. And admittedly, that's fairly simple behavior. It could be more complex than that. But nonetheless, you notice we are saving all of this typing here, which does feel like an excessive amount of typing for such a simple operation. And that's where lambdas are really powerful. Lambda really is the same logic that we've seen before, either in a method or in the body of a for loop. It's just giving us a couple more capabilities. First of all, for very simple methods especially, it takes a lot of that boilerplate syntax away, the curlies and the method name and all that stuff. But for little nuggets of logic that you find all around your program, it gives you a good way to centralize that and not violate the dry principle or do not repeat yourself. That's important because do not repeat yourself means don't copy paste. And if we can avoid copy pasting and put our logic in one place, we're going to have a smaller code base. Smaller code base is like a smaller house. It takes a lot less time to clean. So that's why we like having a small amount of code that does a lot of work, and lambdas are a great way to do this. So I hope you found this video helpful, and as always, I look forward to reading your comments. Thank you.